Hello everyone, here is your college algebra lesson for lesson 1-3 on absolute value and number relationships. The first problem, example number 1, is a lengthy problem. You don't have to write it down, just kind of follow along as I go through it. This is an exact question, the exact question that you're going to have in your class work when you get back. I'm going to read it to you. In hockey, there are 5 skaters and 1 goalie per team. However, penalties can change the number of skaters on ice for a given team. Given below are a series of successive events. Do not reset to 5 for each problem. For Cedarburg versus the visitors. Determine the fraction of Cedarburg skaters, which would be the numerator of a fraction, to visitor skaters, which would be the denominator. Do not include the goalies for these calculations. Plot the fractions on the number line below. Well, I'm going to begin by just kind of thinking about this, and here's my fraction. And it does say that the fraction of Cedarburg skaters is the numerator, so the numerator is the top. So I'm just going to put CB for Cedarburg. And the denominator of the fractions is visitor skaters, so, VIS. So this is a pretty easy problem, and do not, struggle with this. It's just kind of reading through and figuring out how many skaters are on the ice. Now, we're not including the goalie. So if there was no penalties at all and skaters were not removed from the game, it would be 5 for Cedarburg and 5 for the visitors. However, on this first bullet point here in example number 1, it does say Cedarburg receives a 2-minute penalty and is 1 man down. So the 2 here is kind of irrelevant, but it is telling you that Cedarburg is a man short. So normally Cedarburg has 5 skaters, so now they have 4. The visitors did not receive any penalties, so they have 4/5. Later on, you're going to be asked to graph this on a number line, and you could just put a 0 here, and here's a 1, and hopefully you know that 4/5 is a little bit less than 1. If you want to divide these into your calculator, you'd get 0.8 as a decimal. That'd be like 80% of the way between 0 and 1, and you just kind of put a dot there to signify that's where your 4/5 would be. Well, that's it for example number 1. As you go through these, you'll have to read them carefully, and you'll have to read each piece and try to figure out how to do them. A little bit more traditional. You've seen probably these problems in the past where you're using inequality signs. The first one listed here is a less than symbol. The first one. The second one is a greater than symbol. And then this one is a less than or equal to, and this one is a greater than or equal to. As you look at these problems, you have 5/7 over and 4/9. You need to think which one is smaller. Sometimes you might be able to tell, but there are other times where you're going to have to do a little calculations. There's 2 ways to do it. I'll show you both ways. Now, you can't see my calculator, but what I'm doing in my calculator is I'm taking 5 and dividing it by 7 to get a decimal. That's 0.71. So I'll put that right here, 0.71. And then if I use my calculator and I do 4 divided by 9, and I get a decimal, I get 0.44. It's pretty easy to tell if you're comparing decimals which one's larger. Start at the decimal place and then kind of compare the first 2 numbers, and if they're the same, go to the next ones until they're different. But in this case, we got a 0.7 and a 0.4. 0.7 is definitely larger. So I'm going to use this second symbol here, greater than. 5/7 is larger than 4/9. Now, if you do it the fraction way, you can get common denominators, and the common denominator would be 63 for 7 and 9. And then you can take the 7, multiply it by 9, that gives you 63, and take the 5 and multiply it by 9, that gives you 45. And then for the 9, to get to 63, multiply the top and bottom by 7, and you get 28. Now you're comparing the same denominator, so it's really easy to see which is the larger fraction. The 45, 63 over 63 is larger, therefore that's the same as 5/7, and that's the larger fraction. The second one, sketch on a number line. There's 2 little examples I'm going to do for you here. One of them is the x is greater than 2. If you're weak at analyzing these symbols, you might want to write it down. That's greater than or equal to, and that's greater than. And then the backwards way, this would be less than, and this would be less than or equal to. The equal to symbols have the little line underneath. How do you graph on a number line? X is greater than 2. Well, you need to put a scale on your number line. I like to always put 0 on there and then kind of put some markings, and that's 2. You don't have to put a lot of markings, just enough that are pertinent to the problem, and I always like to put 0. So a key moment here is to put a dot at 2. So I'm putting a dot on 2 because of the number 2 right there. Now you need to understand also this dot. If it's an open dot when you're using the greater than or less than symbols, these are open dots. And then it's going to be a filled in dot if you have the equal to signify it includes the point. So because this is equal to 2, also I want to include the point. So I'm kind of filling that in. And then greater than 2 is the number 3, 4, 5, 6, 7, 8, etc. So I'm going to put an arrow moving towards the right to signify all the values larger than 2. Now for the second one, 3 less than x less than or equal to 4. This one here, I'm going to redraw a number line. And this is basically telling me that x is between 3 and 4. So once again, I like to put 0. Here's my 1, here's my 2, here's my 3. That's important, so I'll write it in there. Here's my 4. That's important, so I'll write it in there. Now I'm going to put a dot on 3 because that's the one endpoint. I'm going to put a dot on 4. That's the other endpoint. And because x is between these, it's smaller than 4 but bigger than 3, I'm going to shade in between. So I'm going to make this a little bit thicker here. Now you also have to determine if they're open or closed dots. So if you remember what we did before, the ones with the equal to's have the closed dots. So the 4 here is the one that's associated with the equal to, so that's the dot I'm going to fill in. Alright, so that's example 3. 4. Example 4 is going to have multiple absolute value problems with it, and anytime you have the absolute value of, say, a number, let me do 2. Absolute value means distance from 0. So how many units is 2 away from 0? The answer is 2. If I had a negative number in there, how many units is negative 2 away from 0? The answer is also 2. So basically with absolute values, you just change the number to positive if it's negative. If it's positive, you just keep it positive. But remember, it does mean a distance away from 0. So for this problem here, I'm going to change the absolute value of negative 3 to 3. Was negative, move it to positive because it's 3 units away from 0. And I still have a plus 8. 8, 9, 10, 11 is my answer. And one last problem. For the last one, these are going to be probably the more tricky ones, but they're not too bad. We want to use absolute notation, that's absolute value, to write distance between x and 4. So if I tried to find the distance between 7 and 4, the distance is 3. How did I get that? Well, from 4 to 7, you'd count 3 units away. Mathematically, you would subtract them. So whenever you're doing distance between x and 4, you're going to subtract them. What does this absolute notation mean? Well, you need an absolute value markings around any time you're signifying the distance between things. Because if I did 7 minus 4, I get 3. Well, what happens if I did it backwards and did 4 minus 7? I get negative 3. Whoops, that should be a 7. I get negative 3. Well, they are 3 units away from each other, a distance, but distance can't be negative, so you need to absolute value it to make it positive. So even if you have an x and you can't do the math operation here because you don't know what x is, you still have to enclose it by these little bars, which are absolute value bars. Now, the second part is you need to write, using an equality here, is not more than 3. So I'm going to put a 3 here. Now the question is not more than. I'm going to be using one of these symbols. Is not more than 3. Does that mean it's 2? Or does that mean it's 4 or bigger? Not more. Not more is technically less than. So it can't be any more than 3. And it's also going to be equal to 2 because oh no, it shouldn't be in this case. It's just going to be less than 3. So for this problem here, it's just going to be x minus 4. The distance, using absolute value, is not more, so underneath 3. And that's how you do this. It's pretty easy. When it says distance between, you use absolute value, and then you just have to determine from the second part of the wording, is it less than, greater than, etc. And that's how you do these problems. Hopefully this was helpful. Thank you.